This conference will now be recorded.
Hey guys, this is Naveen here. Welcome back to Naveen Automation Labs and welcome back to JMeter series. So guys, with respect to JMeter, we have see whenever we talk about performance testing, some important terminologies we have to remember. We should know what is the meaning of that particular keyword, what is the meaning of that particular terms that we are using, what is the definition of this? Because whatever the terms that we are going to use, it's totally different from your typical functional testing. Just like we have in Selenium, right? If I ask you that, okay, what is XPath? What is JavaScript? What is CSS selector? What is ID? Right? What do you mean by dev tools? What do you mean by Chrome tools? All those things, right, are part of your web automation or maybe functional testing or regression or okay, you are doing some boundary value analysis or whatever. The typical manual testing, functional testing terminologies are there. Performance testing terminologies are totally different, and in fact, your 1 hour interview, someone can take only on the terminologies. That what do you mean by scalability? What do you mean by connection time? What do you mean by response time? What do you mean by latency and all those things? So these terminologies are very, very important, and we will be using very frequently these terminology in when we talk about any performance testing tool. So these are the common terminologies generally we used in performance testing. Either you are using Scala, JMeter, load runner, or any kind of other automation performance automation tool if you are using it, guys. So it's very important chapter that I'm going to cover today. Please try to understand. No need to remember, I mean that okay, yeah, I mean no need to remember line by line, but you have to understand the concept that what is the meaning of this. These things are very, very important, and you have to explain, okay, with the proper examples or maybe with the proper definition. You have to explain at a time of interview. Okay, don't try to remember the definition. Try to understand what exactly I'm trying to explain for each and every term over here. Okay, so that's why this chapter is very important before deep dive into JMeter. So that's why the first slide you can see that common terms used in performance testing. That performance testing is a obviously practice conducted to determine how system is performing in terms of responsiveness. Obviously, how a system is responding you whenever there is a load, whenever there is a peak time, whenever there is a number of users we are okay getting increased. In that case, we are going to check the stability of the system under a particular workload. We say that okay, yeah, today only 10 users are there, no impact, but tomorrow suddenly 10,000 users are there. Then how exactly your system is going to behave? Functionality wise, it's absolutely working, but is my system is capable enough, okay, to handle such kind of load or not? So a lot of attributes came into the picture. You have to do a lot of investigation. You have to measure a lot of matrices. You have to validate a couple of things in terms of response data and everything. And then you have to verify quality attributes also of the system, such as scalability, reliability, and what kind of resources being used by the system. So that's why these terminologies are very, very important. So let's go to the next slide and let's see. So these are the common terminologies: connection time, response time, and throughput. And most of the people, they give the wrong answer for these three things. So what is connection time? See guys, connection time is to connect to the server from the client. So obviously whenever we talk about client and server architecture, so let's see, this is my client and this is my server, right? So I quickly write, let's see, this is my client, and try to understand exactly same thing you have to explain at a time of interview. This is my server. So client is sending a request to the server. This is called connection time. Okay, so let's see, my request connection time is equal to around, let's see, it took 75 milliseconds. Okay, it's taking around 75 milliseconds to connect to the server. So this is a request that we are sending it, okay, to the server, right? So we are sending a request, and this is called connection time, that you are going to connect with the server. So here the connection will happen with the help of TCP IP protocol, the transfer connection protocol, and IP address we have to give and all those things. Okay, if the handshake between client and server is successful, then the connection has been established and server will understand the request. And let's see, it's taking around 75 milliseconds to connect to the server. And you never know where exactly the server is available, in cloud machine or on AWS or anywhere, right? Now, connection Connection has been established, and client can easily server is easily understand, okay, this is a request, and server now sending the response, right? Sending the first response, and this is taking around, let's see 25 milliseconds it's taking for the response. So right, so this is called response time, guys. Remember this thing. This is called what? Response time, RT. So response time we are getting, let's see, it's taking around 75 milliseconds. Okay. So response time means when we send the request, it will make the connection with the server, and then we are getting the response. So we are doing what? We are doing one loop over here, starting from the client, going to the server, and coming back to the response. The response is coming back to the client, right? Client could be anything. It could be, let's see, your browser or your mobile application or whatever, right? So this is a loop we are creating, and once the first loop is done, that is called the response time. The moment we get the first response from the server is called response time. Now what happens? The response can be given further also in the form of different packets. Let's see number of packets are coming from the server, and let's see number of requests we are sending, and we are getting number of response over here. So let's see, within 1 second, okay, within 1 seconds we are doing around 10 different requests. Okay, so what I'm saying is within 1 second we are doing around 10 requests. So can I say that 10 requests per second, right? I can simply say that 10 requests. Let me write some. Okay, 10 requests per second. So this is called, guys, throughput. Okay, if you see the definition now of the throughput, throughput means throughput means indicates the number of transactions happening per second on an application can handle, the amount of transaction produced over the time during a test. Now the request, it could be per second also, request calls per second and hits per second, or reports per year also. So per year is also, I mean, it's a very rare scenario. So this is called throughput. Remember this thing. Okay, so this is the definition of these things. Now 1 second, guys. Yeah. Now the next thing is scenarios. What do you mean by scenarios? So scenarios means whenever it's a typical business flow, whenever we are making, let's take an example of Amazon. On Amazon, what is a typical scenario? You just search the product, then add to cart, make the transaction, and then get the order history. So that is called my transaction. That is called my scenario. So scenario in context of performance testing is the sequence of number of steps that you are performing. It means, let's see, to perform a single scenario, you are sending the request to a server multiple times, and then you are performing a one business flow, one business scenario. So scenario can represent a use case or business function, such as, let's see, searching a product catalog on an e-commerce site, adding an item, shopping cart, or placing the order. So this is a complete scenario I'm talking about, right? So that's why remember this thing, scenario and transaction both are same thing over here. Then let's talk about bottleneck. Bottleneck is a very common term. It's used to describe a single part of a system that prevents further processing. So let's see some bottleneck. You have written some really bad code, and then your request is stuck over here and server is not able to respond back. So that is called bottleneck. It means my server got stuck over there. My server is jammed over here, and then we are not able to send it back to the client. So in that case, we are getting a bottleneck situation. That it means you have written either such a poor code like that. So it's going to degrade the performance of the application of the system as a whole. So that prevents further processing or significantly degrades the performance of the system as a whole. So this is called bottleneck. Capacity. Capacity means the degree to which a system can perform data processing until performance degrade. It means, for example, let's say number of new customers being added to a database. So what is the capacity of my server? How many data, how many users I can do that, okay, in a particular time period? That is called a capacity, the capacity of my server. Concurrency normal, we know that okay, number of multi-user then okay will participate. Normally this means number of simultaneously virtual users driving transaction across the user journey in a given performance test scenario, right? Concurrency means concurrent users are there, and simultaneously number of virtual users or number of users they are going to hit the server, like that. And can also mean the number of transactions synchronized to happen at exactly at the same time. It means, let's see, um, I'm searching for Apple MacBook, and 10,000 people are there. 10,000 users are there. Assume that okay, they are behaving like a virtual user and searching for the same Samsung phone or Apple MacBook and doing the same exact transaction. Or let's say you are going for a movie, right? And then you are going for a movie, and 100 people are booking the same movie ticket for the same slot, let's say 6 o'clock in the evening, for the same movie and for the same row in the theater. So that is also a okay concurrency, right? Sometimes we see that okay concurrency. If see let's see the movie tickets and the seats are reserved by me. Now you cannot do that. So other user is cannot do that. So that is called concurrency concept over here, right? Then we have key performance indicators. So that we will talk about later, okay, better. But set of target which we have to set the targets over here that what exactly the kind of expectation for your performance testing point of view of your system, especially with the production. So performance testing is very important for production point of view, guys. Remember, it's not like that. Okay, I'm going to measure my performance. Okay, performance testing for my QA environment or dev environment, because QA and dev is very limited users. Actual users are hitting the production server. So here I'm going to set some targets. This is the benchmarking. This is the expected performance target for my application that uh, let's say for Amazon or let's say for Uber, they should be able to handle such scenarios within this particular period of time, like that. Okay, so response time, let's see, so we talk about, right? You must be hearing about that. Okay, hey, let's see, for login, it should not take more than uh, 2 milliseconds or 5 milliseconds or something like that. Okay, 99% of the page loaded, it should be less than 2 seconds. If it is taking more than 2 seconds or 5 seconds or sometimes 10 seconds, then it's a bad design or something that we have to improve the performance, like that. What is the CPU uses? What is the free memory allocation that you are having? What is the threshold? And all those things, okay, we will be talking. Okay, number of KPIs we have to define. What is your hardware? What is your logging space? What is your disk usage? See, the CPU utilization, what is the memory leak, what is the memory utilization you are using it, okay, in your system. So all these things you have to define some KPI. Just like, let's see, for my company, in 6 months or next quarter, what are my KPIs, what are my goals? These are my performance goals, right? Same thing, the performance set goals you have to define for your system as well. So these are called KPIs. Now, very common term, load testing. So it's a typical type of performance testing. So what we are talking about, whole soul, I mean, we are talking about performance testing. It's a huge umbrella. In performance testing, we have load testing where we are going to test the behavior of a system. So remember, guys, so it's not about that, okay, behavior of the system you are going to check. In the particular system, we have a specific component also. Let's say I'm just going to check my search component. I'm just going to check that, okay, seller component. I just want to check that, okay, on Uber, that only searching the driver component, or maybe let's see the transaction component. So it's not about the entire system I'm going to check, or it could be a component also. When the load on the system, I'm going to provide different types of load over there, okay, via users or different transaction with the same user. I'll do it back to back, or multiple users, I'll okay doing the same transaction. And in that case, I'll check uh, you know uh, what is the system is behaving, how exactly system is behaving. With the load testing, I'll be performing by providing a different types of load over here. Remember this thing. So let's see, in the morning, let's see, I'll be providing some load. So it will be like this. So assume that okay, this is x and y coordinate. So I'll be giving some load over here, and then the system number of users I'll be keep increasing, like that. So I'll be checking that okay, this is the time, and these are the number of users I'll be keep increasing over here, like this, right? So number of users, and accordingly the time will be taken by number of users. So let's see, if you have 100 users, so more time will be taken. If you have only, let's see, only one user, right? If you have only one user and you're taking only 1 second in that case, it's very fast. So the moment you increase your number of users, so automatically your time also will be increased over here, like that. Okay. Then we have non-functional requirements. So this is also a very simple term. Requirement means, let's say we are getting the functional requirement, which is like, hey, you have to create this login feature, search feature, and all those things. But in terms of, you are getting a requirement from the client for a system that, okay, hey, you have to check the reliability, you have to check the performance, you have to check the stability, you have to check the usability of the system. These are called non-functional requirement of a particular system. The system is functionality wise is absolutely fine, but non-functionality, let's say security point of view, performance testing point of view, reliability point of view, how exactly my system is behaving or not. Then performance engineering is a very wide area, guys. It's very, very important that what is performance. Okay. Performance engineering. So performance engineering means whatever we are doing in terms of performance testing and everything, there is a separate I would say, separate scope that is called performance engineering scope. It's a separate activity actually. We will ensure a system will be designed and implemented to meet specific non-functional requirements. So this team, performance engineering team or performance engineering activities, they will ensure that, okay, whatever the non-functional requirements are available, we have to fulfill those non-functional requirements. Okay, all those non-functional testing activities we have to fulfill, and we have to highlight all the weak points, the weaknesses in the design and the implementation. What kind of weaknesses? Let's see, these are the top 5 SQL queries which are taking a lot of time. You have written unnecessary inner joins or unnecessary inner queries you have written, and which is taking a lot of time to produce the data from the database, and then only it will display on the server. So that's a weakness, that's a design problem. You are not, you have, your design is so poor that, okay, that unnecessary objects you are creating, unnecessary heap size you are taking, your code quality is so bad. In that case, code quality means the developer code quality, that whatever they have written, they are not following the proper design patterns and everything. So performance engineering team, they will say that, okay, yeah, it's going to impact the performance, right? So that's the activity of performance engineering. So remember, people might ask you all these things at a time of interview. Not might be ask you, definitely they will be asking you. Then performance testing plan, just like functional testing plan, we have a typical written document, details of the what kind of objective it is, what is the scope, what kind of approach you are going to follow, which tool you are going to use, that what are the deliverables from your side, scheduling, risk, data, test environments. Okay, what kind of performance testing environment you will be using for for that particular project, and all those things you have to write inside this particular test plan documentation. Then we say that, okay, performance testing, it means testing designed to determine the performance levels of the system, that we have already talked about it. Then these 3 4 terminologies also, guys, you have to remember. Reliability, how system is reliable. It's all about the system stability. Reliability is a degree to which a system provides the same result for the same action over time, over the period of time under load. Then how system is reliable? Can I trust your system? Can I trust your application? Yes, I can trust your application. You just give me the load. Under the load, for either you're providing 100 users, 1000 users, or 10,000 users, or 100,000 users, my system is reliable. My system is strong enough to reliable. Just like Google, let's say the millions of people are hitting Google server, right, daily basis. We are searching on Google, and Google is a search engine. So there is a server is responding, is so reliable. You never see that, okay, Google and YouTube are getting down, because they are so reliable systems, right? So that's why this is the factor that we have to check, the reliability. Scalability is very important. Scalability means the degree to which a system performance and capacity can be increased, typically by increasing available hardware resources with the set of server. It means your system is scalable or not. It means you um, doing horizontal scaling or vertical scaling means number of hardware you are going to increase. I wanted, okay, hey, uh, instead of 5 hardwares, I'll be having 10 different hardware machines or to my data centers, and 10 different hardwares are having these number of Tomcat servers, and this is a RAM, and this is the storage capacity and all those things. So this is the factor that we have to do that with respect to scalability. Then soak testing. It's a typical type of testing used to evaluate the behavior of a system or a component when the system is subjected to expected load over a sustained period of time. Okay, a typical period of time you are getting a sudden load. So in that case, we are going to check the performance of the application that, okay, hey, just let's see, um, between 7 to 9 in the morning, I want to check the load, right? And then evening 6 to 7, I want to check the load. So for a period of time, I want to check out, okay, hey, what kind of application is behaving. In that case, I'll be using with respect to soap testing. Then we have spike testing, guys. Spike testing means same thing, but how the system is responding to a large increase in the demand. Let's see, everything is normally working fine, and suddenly, after 2 days, Thanksgiving Day is there, or Diwali season is there in India, or let's say Christmas or New Year, and suddenly the load is getting increased, right? Black Friday, or where a lot of people they do shopping in US, not in the US, worldwide, and suddenly on Amazon or Flipkart, and suddenly the peak time is there, and then how exactly the spikes are coming. So spikes will be generated in a particular graph like this. So let's see, this is the graph, and suddenly the load is normal like this, okay, in a normal days, and suddenly on Thanksgiving Day the peak is coming like that, and then the peak is getting increased like that, okay, like this, okay, and then after Black Friday, Sunday, Saturday, then Sunday, and then Monday again, it's normal like that, right? So on Black Friday, or Friday, Saturday, Sunday, you can see the spikes over here, okay. It means your system is getting a lot of users over here, you can see that like that, and that's why it's taking some time accordingly, okay. So this is the spike testing that we have to check. Just like you can see that, okay, user logins, Black Friday, okay, event, sales event, or something like that, okay. You are giving some let's say Diwali season or Diwali sale, Christmas sale, or something like that. Stability, the degree to which a system exhibits failure and errors when under normal uses. For example, okay, some error when registering new user load. So that is the stability of the factor that, okay, of the system that we are going to check, that you are going to register, let's say example, registering a new user under that particular load, and how system and 100 registration or 1000 or 10,000 registrations you are doing. So you're going to check that, okay, out of 1000 registration, how many failures are there, that you are going to check the stability of the system in that case. Then stress testing, again we can see some example that, okay, what is the difference between load testing and stress testing. So stress testing means a typical performance testing to check the behavior of a system of the component when subject to load beyond the anticipated workload, right? So let's see, I'll give you an example. There is a bulb, or there is a tube light. 60-watt bulb is there, and 60-watt bulb is absolutely working fine up to, let's say, you started with the load, giving the load 50 watt, 50 watt, 60, 62, 63, 65 is fine. It can bear the load, and suddenly the load is getting increased to 70 watts, and immediately it's burst, right? So that is called the stress testing. Sometimes we see that, okay, immediately sudden load is coming, you never know. Let's see the big billion day. Remember that Flipkart happened 4 5 years back, the big billion day, early morning, 6 o'clock, 6 to 10 o'clock, or 6 to 8 o'clock. A lot of transactions were happening and system were down because they were not they did not do any stress testing with the system, right? So in that case, you will be checking a couple of factors that, okay, how exactly my system is behaving whenever there is a sudden load is coming like that. So I'm not talking about a sudden peak. System is let's see, is like that normal, okay, hours are running, 4 o'clock in the morning, 5 o'clock in the morning, and then suddenly 6 o'clock in the morning, sudden peak is there like that, okay, and then it dropped, right? So at this particular uh, peak, we are going to check, we set the benchmarking that, okay, my maximum load 10,000 user I can take it, but suddenly 40,000 users are hitting the server. Are you getting a point, right? As a performance engineer, performance tester, I have given that, okay, hey, 20,000 or 30,000 is the benchmarking. I can bear the cost, I can bear the load, but suddenly it's going increase to 40,000 or 50,000 or 60,000. the peak is coming. So it means we're going to check the stress, what is the maximum threshold value I can bear it, okay, with respect to my system. That is called, guys, stress testing. Okay, so remember, difference between load and stress. Load means you are passing the different load. One user, this is the time. Then you increase to 500 user, this is the time. Then 600 user, then 1000 user, then 10,000 user, then 20,000 user, then 50,000 user, like that. So this is different loads you are providing, and then server is taking, okay, time accordingly to respond it back. So that is different load testing you are performing it. But the stress testing is always you are going beyond the threshold value. Okay. Then this is again the transaction volume model, TVM. A document dealing the user journey to be simulated, the click path steps that make up the user journey and associate load per transaction volume models to be tested over here. And this should include information regarding the geographical locale from where user will be expected to interact. This is very important, that okay, what kind of the device and what kind of geographic location that he is using, okay, to access that particular system, and the method of the interaction also, either it is mobile and desktop. So transaction volume model we are going to define. It's a kind of documentation that from which device, from which location, okay, the system is getting hit. Okay, so in that case we will define some TVM, transaction volume model also, like that. Then the user journey, the path through the system under test that a group of virtual users or users will use to simulate the real users. Okay, it should be noted that key performance per volume impacting journey should be used as a impractical to performance testing all possible user journey. A good rule. So we'll talk about what do you mean by 20% of the users that generate 80% of the volume. So 20% of the user journey generate 80% of the volume, and how exactly we can do the volume testing over here. So the user journey, simple. Number of virtual user will use to simulate the real users. So we will generate, especially in JMeter, let's see, we will generate number of threads, number of virtual users, which will behave like a okay, real user, and which will behave like let's say 80% of the volume they will generate. So we'll talk about that also later. Then what do you mean by virtual user? So virtual user means that, obviously, let's see, if I say that, okay, hey, this is the system, Amazon, and you have to hit with 500 users. So you are not going to use 500 laptops, right? So you have to use 500 virtual thread users, number of threads you have to use it, right? So that is a typical thread user you will be using it, guys. So these are the important things that you have to understand, you have to know about. Okay, what do you mean by scalability, reliability, connection time, response time, throughput, what is scenario, bottleneck? Okay, all these things you have to understand, because these are the very important interview questions as well, guys. Okay, so because don't take it lightly, don't feel that okay, why Naveen is explaining all this theory and all, because guys, this theory is important to understand, because you all are coming from the functional testing background, not from the performance testing background. Okay, so guys, that's why that we have to understand these terminologies. Otherwise it will be very difficult for you guys to understand that how exactly, let's see, tomorrow I'm saying okay, hey, this is the throughput, and then what is the, okay, then what is the response time, then what is the concurrency, then what is the threshold, what is the rangeover point, and all those things, all these terminologies you won't be able to understand. Okay. So that's all for this particular video. A lot of other terminologies also are there, guys. A lot of other definitions also there. We will be covering with the course, with the videos, new videos. So, but these are the common terminologies generally we use that. Okay, if you have something specially, let's see, SE specific terminology you really want to know, we just put a comment section over there. Write a comment over there in the comment section. I'll have a look and I'll try to explain in the next video. Okay, so thank you so much, guys. Thanks for watching this, and I hope you guys are learning. I mean, we just started, so please write your notes with respect to all these terminologies, and let me know if you have any issues. So please subscribe to the channel if you really like this video. Thank you so much. Thanks for watching Naveen Automation Labs.